Okay, so today we're looking at graphing linear equations using slope-intercept form. This is from section 4.6 in your Algebra 1 textbook. And really it all comes down to one essential formula. And that essential formula is y equals mx plus b. Now, if you've never seen that before, it's okay, but you should know that this formula right here, y equals mx plus b, is going to be essential to any study of linear functions that you have over the next several months. Once you get a formula into y equals mx plus b, and don't worry about what it means right now, but once you get a formula into this format, you need to understand that that number that sits right in front of the x, which is denoted by an m, that m stands for slope. And that tells you how steep your line is going to be. A slope of 0, for argument's sake, is a line that is horizontal like that. If you're trying to, if it represented a ski slope, for argument's sake, and you had skis on, you wouldn't get very far because there's 0 slope there. And your slope would be 0. But as your line gets steeper and steeper and steeper, the value of your slope is going to increase. Now, I've read a great deal of math history books, and I know all kinds of things about math history, but as for why the variable m is used for slope, I don't know. In fact, there are a number of books that claim that it's a mystery. I'm not sure. I don't really care, to be honest. If the m represents the slope, then this number b tells you what your y-intercept is. And when I say y-intercept, what I mean is where the line crosses the y-axis. So if I drew a line, for argument's sake, that looked like that, its y-intercept is right there, that point. It's where the line crosses the y-axis. So let me show you what we do when we're asked to write the equations in slope-intercept form. So the directions say write the following equation in slope-intercept form. And what that means is you want to get y alone. You want to have this equation get in the form y equals mx plus b. So if I'm looking at 2x minus 4y equals 16, and my objective is to get y alone, the first thing I'm going to do is I'm going to subtract 2x from both sides of the equal sign. So I'll subtract 2x here, and I'll subtract 2x here. And once I do, I'm left with negative 4y equals negative 2x plus 16. Now, a lot of kids have a hard time with that because they want to write 16 minus 2x, and I can understand that. 16 minus 2x wouldn't be wrong, it's just not in standard form. If I want to have y equals mx plus b form, what that means is I want y on the left-hand side of the equal sign, for argument's sake. It could be on the right-hand side. And then I want it to equal some number times x plus or minus some other number. So I've got to have the x term come first and the constant term come last. I'm still not done in getting y alone in this case. I want to divide each piece by negative 4. Everything gets divided by negative 4. Once I've done that, the negative 4 over negative 4 cancels because it's equal to 1. So I'm left with 1y equals 2 over 4. Now, the number one most common mistake among especially young kids taking algebra is that they see 2 over 4 as 2. It's not. 2 over 4 is a fraction, and it can be reduced to 1/2. A negative over a negative is a positive. So I'm going to write this as y equals 1/2 x. And now I've got positive 16 divided by negative 4. A positive divided by a negative is a negative, and I'm left with 4 there. If I have to identify the slope and the y-intercept, I know that my slope is that value sitting right in front of the x. It's 1/2. And my y-intercept is this constant term after the x. It's negative 4. Knowing those two values, I could go ahead and graph this line, but I'm getting ahead of myself. I want us to practice right now just getting random algebraic linear equations into y equals mx plus b form. So let's look at a second one. Y equals x plus 3 all over 2. And I could write that this way. X plus 3 all over 2. I didn't write it that way because the typing thing I'm using didn't allow me to. Not handily anyway. All right, so as I rewrite this, what I realized is that x is being divided by 2 and 3 is being divided by 2. So I could rewrite this as y equals the 1/2 x, because there's really a 1 sitting in front of that x that we take for granted, plus 3/2. Once I've done that, I have my slope sitting right there. My slope is equal to 1/2. And I'll tell you what that means in a couple of seconds. And this line crosses the y-axis at 3/2. So the y-intercept is 3/2. Those two pieces of information in a couple of minutes are going to allow you to graph linear functions really easily without having to make a table. Making tables is something you can always fall back on, particularly when you get into functions in pre-calculus that you don't readily recognize. You'll see some function and you'll think, oh my gracious, what am I going to do with this? Well, you can always rely on creating an XY table, plugging in values of X, getting out values for Y, and plotting those points. Unfortunately, it's kind of a laborious procedure, and it's not always the best method for getting things done. It's not always the most efficient method for getting things done. I think in graphing linear functions, the slope-intercept form of graphing is the most efficient. So let's look at y equals negative x plus 2. In y equals negative x plus 2, we're taking a number for granted in front of that x. And what I mean by that is that we realize it's there, but we don't write it. In this case, it's a negative 1. So I'm going to rewrite this equation as y equals negative 1x plus 2. When I do that, once again, I know that my slope is the number right in front of x. So m in this case is negative 1. I'm going to write it in fraction form on purpose. It's negative 1 over 1, and I'll need that. Again, I'll need that later when I'm about to graph. And this number right here after the x, that's my y-intercept. It tells me where this line crosses the y-axis. In this case, my y-intercept is 2. All right, finally, we have the equation y equals negative 4. Well, if you wanted to, you could rewrite this as y equals 0x plus 4. You notice in the initial equation, there is no x term. Well, there is an x term. It's just multiplied by 0. So here's what I know. I know that the slope of this line is 0. And if you remember, that means I'm the skier who's not going anywhere. And the y-intercept here, my value of b, is 4. I'm sorry, negative 4. This should be a negative 4. I apologize. And that tells you where this linear function crosses the y-axis. Well, if you think about that, and here's negative 1, 2, 3, 4, what that means is I'm going to have a linear function whose slope is 0 and crosses the y-axis at negative 4. It's just going to be a horizontal line. That's all it's going to be. All right, so that's just a quick primer on how to get linear functions into y equals mx plus b form. Now I'm going to show you how to use that. So our next directions say graph the following equations. And the first equation we're given is 3x plus y equals 2. Well, if you wanted to fall back on the old create a table method, go ahead. You can do that. But that's not the topic of what we're doing right now. The topic of what we're doing right now is graphing these equations using slope-intercept. So I've got to find the slope, and I've got to find the intercept. My first job is to get y alone. So in this equation, I'm going to subtract 3x from both sides of the equal sign. Once I've done that, I have y equals negative 3x plus 2. I now have this in the form y equals mx plus b. I know that my slope for this particular equation is negative 3. I'm going to write it as a fraction, negative 3 over 1, and I'm doing that on purpose. I also know that my y-intercept is 2. That helps me do the following. I'm going to flip over to my xy axis. I'm going straight to 2 on the y-axis because I know this line crosses the y-axis at positive 2. Furthermore, I know the slope of my line is negative 3 over 1. Now, up in the upper right-hand corner here, I'm going to write this. My slope is negative 3 over 1, which is the change in y over the change in x. That's what a slope is. Some teachers will tell you that it's rise over run. And that's okay too, as long as you understand that rise is the y direction and run is the x direction. So, the first thing I want to do is I want a y change of negative 3. Well, on the y-axis, negative means move downward. So I'd move down 1, 2, 3 points. And I want an x direction change of positive 1. Well, in the x direction, positive means move right. So I would move to the right 1. I've moved down 3, right 1. That's my slope. Repeat process, down 3, right 1. Down 3, right 1. I've run out of space on my xy axis. So if you understand in fractions that -3 over +1 is the exact same thing as +3 over -1, you're home free because you can go back to your y-intercept, and instead of traveling down 3, right 1, you can instead travel +3, which is up 3, and -1, which is left 1. Put a point there. +3, left 1, until you run out of room. Now, once you've done that, you can see that all your points here line right up. You want to grab a ruler every time you write or draw these lines. And the reason you want to grab a ruler is that you want to be as precise as possible. There's going to come a time where we graph 2, 3, 4 lines on the same set of xy axes, and we're going to look for where they all intersect. Well, if you're off by even a little bit on any given line, that point of intersection can change drastically. So you want to be very careful. That said, I don't have a ruler on my smartboard, so I'm going to do this as best I can with my line function, and we'll hope that everything comes out all right. I want a line. That's a line segment, but nonetheless, I'll start here, and I'll go through that point there. Boom. The next thing you want to make sure you do is to put arrows on both ends of the line, indicating that they go on forever, because the line is composed of infinitely many points. And you want to label the name of your line. In this case, it was y equals -3x plus 2. All right. Now, that's just the first one. My advice, if you're using graph paper at home, is to graph up to 3 linear functions on any given set of xy axes. After you do more than 3, it starts to get really messy, and you stop being able to tell what work you've done well and what work you haven't done well. Let's go ahead and graph a second one. So my second line is y equals 1/2 x minus 2. Just in looking at this, I know that my slope for this function is 1/2, because that's the number in front of x. That tells me my change in y over my change in x. I also know that my y-intercept is -2 in this case. So my slope is 1/2, my y-intercept is -2. When I go to my set of xy axes, the first thing I want to find is my y-intercept. So I go to -2 on the y-axis. That's where this line is going to cross the y-axis. Thus, it's called the y-intercept. I'm going to just do some erasing real quick. I want to get rid of some of this stuff. Now, my slope for this function is 1/2. So up here, I'll write m equals 1/2. And I know that's equal to my change in y over my change in x, which is my rise over my run, if you will. +1 in the y direction means up 1. +2 in the x direction means right 2. So from my y-intercept, I'm going to travel up 1, right 2, and put a point there. Repeat process. Up 1, right 2, and put a point there. Up 1, right 2, up 1, right 2, up 1, right 2. I'm going to keep doing it all the way across the xy axis until I run out of room. Now, I'm going to go back to another idea about fractions. If you understand that 1/2 is the exact same thing as -1 over -2, because a negative over a negative is just a positive, then you can start right back here at your y-intercept and travel down 1, left 2. Down 1, left 2. Notice these points are obviously on the same straight line as what we started with. Okay. I'm going back to my function here. I am creating this as neatly as possible. I am putting arrows on either end, indicating that the line goes on forever, and I'm naming it y equals 1/2 x minus 2. All right, I'm set with that one as well. Now, notice that the two lines we've already graphed had different slopes. The first slope was -3, and the next slope is 1/2. They're not the same, so they don't have the same steepness. I want to point something else out. If I read from left to right on the x-axis, the first line we graphed, the one that we graphed with red dots, is decreasing, and it has a negative slope. That's not an accident. Negative slopes decrease as I read from left to right. Positive slopes increase as I read from left to right. 1/2 is a positive number. As I read from left to right, this line is increasing. Okay, that's just one way to check to see whether or not you've messed up. All right, let's go back to the last one we have here, I think. I'm looking at y equals 1/2 x plus 6. Okay, we'll do this really quickly. My slope here is 1/2, which is my change in y over my change in x. It's really important to write that change in y over change in x down, otherwise you're going to mess it up. And my slope is equal to positive 6. When I go back to my graph, I'm going to go to positive 6. 1, 2, 3, 4, 5, 6 on my y-axis. I'm going to put a point there. And my slope is 1 over 2. Up 1, right 2. Up 1, right 2. Up 1, right 2. Continue until I run out of room. Up 1, right 2 is the same as down 1, left 2. Excuse me, down 1, left 2. Keep going all the way across the xy axis in order to maintain or to enhance accuracy. Okay, I'm going to go to this line function, which sometimes is decent and sometimes isn't. And I'll do that. I'm going to put arrows on both ends of the equation. Y equals 1/2 x plus 6 is its name. Now, my final question. What do you notice about the two lines that I graphed? I'm sorry, the second and third lines that I graphed. If you said that their slopes are the same, you're absolutely right. They both had a slope of 1/2. And the result of them having the same slope is that these two lines are parallel. Parallel lines have equal slopes. Okay, I hope this helps you with your homework. And remember, just as a form of space management here on paper, when you're graphing lines, don't do any more than 3 on any set of xy axis, otherwise it starts to get pretty messy. But in the interest of saving as much paper as possible, you do want to do as many as 3 on the same set of xy axes. And don't forget to label every one of the lines with its name so that you know what you've graphed and what you still have to do in terms of your homework. Okay, good luck with this section.